Let's start with an example. Again same, we want to convert epsilon NFA to NFA. Okay, so let's start with this. Now let us say the language is A star, B star, C star, capital A, capital B, capital C. Okay, so in order to convert this epsilon NFA to NFA, I have to construct the transition table. Transition table is going to look like this: capital A, capital B, capital C. Okay, so inputs are A, B and C. Fine. So I have to find out what are the transitions on capital A on small a in case of NFA. In order to find it out, I'll write like this: I'll find epsilon closure of A first, and then A, and then epsilon closure. What is epsilon closure of A? What are all the states which I can reach from capital A only on seeing epsilons? One is A, other is B, and other is C. Fine. And what are the states which I can reach? Okay, and then it is small a. On small a can reach A, and what about B and C? B and C will stop there. They will die. This is called dead configuration, right? So they are not going anywhere. They will die. What about epsilon closure of A again? Epsilon closure of A is A, B, C. Therefore, this entry is going to contain A, B, C. Fine. And now we have to find out what happens on B and what happens on C for capital A. So everything remains same till here. Now I have to find out what happens on B. Fine. So capital B on small b, capital A on small b is going to 5, which means it is going to die, and capital B on small b is going to capital B itself, and capital C on small b is going to 5. What about epsilon star? So capital B on epsilon star is going to, which means epsilon closure, it is going to B, and one more thing is capital B on epsilon is going to C. Therefore here I am going to write it as B comma C. Fine. And now what happens on C? What happens on C? Capital A on C is going to 5, because capital A doesn't have any move on C, and capital B doesn't have any move on C, it is 5, and capital C on C is going to capital C itself, and epsilon closure of capital C is capital C. See, this is capital C and this is small c. Fine. And next thing is I have to discuss about capital B. Capital B on small a. So what is epsilon closure of capital B? Epsilon closure of capital B is, one is it will contain B itself, and the other is it will contain even C. So B and C are the epsilon closure of capital B, and capital B on A is 5 and capital C on A is 5. Therefore it is going to die there. So capital B on A, it doesn't have any moves. Now capital B on B. Now what about capital B on B? Capital B on B is going to be capital B, and capital C on B is going to die. 5. And what about capital B, epsilon closure of capital B? Epsilon closure of capital B is going to contain one is B as well as C. B and C, that is epsilon closure of B. Therefore I am going to write it as B, C. And capital B on C. Capital B on C is going to be, capital B on small c doesn't have any move, therefore it is going to be 5, and capital C on C is going to be capital C itself, and epsilon closure of C is going to be C. Therefore I am going to write it as C. What about capital C? Now capital C on A, capital C's epsilon closure is C itself, and C on A is simply 5, therefore it is going to die. 5. I should not write 5 like this, right? I should be writing 5. Phi is nothing but empty set, right? I should not include phi inside a set. It means that it is a singleton set which is containing an element phi. So that is wrong. Fine. Next thing is capital C on B. What is capital C on B? Epsilon closure of C is C itself, and capital C on B is going to be phi. Therefore everything is going to die, empty set. What about C on C? Epsilon closure of C is C, and C on C is going to C, and again epsilon closure of C is C. Therefore this is it. So if you draw the NFA for it, NFA will look something like this: capital A, capital B, capital C. On small a, it will either be here, or it will go to B, or it will go to C. And on small b, it will go to B and C. B and C. And on C, it will go to C. Next one, B. Capital B on small b is going to BC. B, B. And capital B on small c is going to C. BC. What about capital C? Capital C on A doesn't have move, capital C on B doesn't have move, but capital C here it will have move, which is C. Fine. So this is how the NFA has been constructed. Now tell me, what about the final states? Number of states are going to be same. If I convert epsilon NFA to NFA, number of states are going to be same. What about the final states? So here let us assume that here the final state is C. In the original diagram, final state is C. Then whatever states can reach the final state, only on epsilon is going to be final state. So C is going to be final state definitely, and whatever states which those can reach the final state just by looking epsilon, they have to be included. If you look at B, it can reach C just by looking epsilon, therefore B has to be final. And if I look at epsilon on A, then I am going to reach the final state, therefore A has to be final. So this is the NFA. We constructed the NFA for the given epsilon NFA. And now you will understand that since we have already constructed a DFA, see, we have converted NFA to DFA, so epsilon NFA to NFA, and we know that we can convert NFA to DFA. Therefore you can know that I can convert epsilon NFA to DFA. So all the finite automators are equivalent in power. This is the final answer.